Hello, this week we're going to be looking at arrays. So an array is going to be our first data structure. It's kind of a way of organizing data in a way that is a bit more robust than just individual variables. I mean, I guess in a way, sort of a base level, a variable might be our first data structure. But regardless, an array is like a variable. So if you think of a variable as a box that can hold a value that has a name, let's say, then that would make an array kind of like one of these boxes, right? It has a name, let's call it my supplement box, and it's really, though, when you think about it, lots of individual boxes all contiguously connected together. That's an array. An array is contiguous memory locations that have been assigned, given a name for the very first location, and you can store several different values in there. You can make it have as many elements, as many boxes, I guess, as you want, or as little. And kind of like this box is indexed by the days of the week, right? So you know which day you're supposed to take what supplements. An array is indexed by integers, starting with 0 and then moving up, which the 0 thing is going to get a little confusing at first, but you'll get used to it. Really, it's just a way of saying, like, hey, I want to have a data structure that can hold 100 integers. And so then, maybe this is going to be used to record, scores on a standardized test or who knows what. But then I can essentially say, hey, I then want to put in the first value at index 0 of my scores array. And I want to put the next value in index 1 of my scores array, etc. And I can hold 100 different integers. And I can grab them all using that same name. That's an array. So let's get into how we actually use it. All right, well, let's start with how to actually declare an array. So there's actually two different ways you can declare an array. I'll start with the sort of simplest. First, we need to start with the type. So now an array is not just a type all on its own. An array has to hold a certain type. So it could be an array of integers. It could be an array of strings. I'm going to start with integers. So if I want to create an array of integers, the type for that would be integer array. We use those two square brackets to sort of represent an array. But their compiler will now know, okay, so this is going to be an int array. That is the type of the variable that I'm creating, which is actually going to have room to hold several different variables. Let's go ahead and stick with our scores idea. So I'm going to call my array scores, so it can hold various scores. And there's two different ways I can do it. I can actually just leave it at that. If I did, I would then actually have to allocate memory for that scores array at some point later. Probably I'm going to create both immediately. And so I can start by either using an array literal to essentially create the array, allocate the memory. An array literal is just going to be curly braces. And inside of the curly braces, we could have different values separated by commas. So here 95, 89, 76, maybe 93, and a 56, right? Semicolon at the end of that line, and I've created an array that holds 5 different values, and the 5 values are already initialized. I've initialized that array with a literal. The other way that I can do it is to say scores, same thing, int array scores equals new int array, but inside of the square brackets here, I'm actually going to put in a number, in this case 5. I have the exact same type of array as I had before, an array that can hold 5 different integers. But in this case, all of the integers are going to have the value of 0, right? They're going to get zeroed out. There is no values put in them yet. I've just created enough space to hold 5 integers, and I can change the values later. Either way works, however you want to do it. I'm actually going to go back to my initial version, just so that we have some values in there to play with. So if I want to, let's say, assign a value, right? Well, actually, let's just first, how do I actually reference an individual value? I'm going to use my sout little cheat. And let's say I want to print the first value in the array. Well, that would be scores sub 0, because our indexes start with 0. The reason our indexes start with 0 actually has to do with the way it's stored in memory. That what that represents is go to the scores location and go up 0 elements. So 0 elements means don't go anywhere. Start right there at the very beginning and then read 4 bytes, which is the size of an integer, to get the first value. If I put a 1 there, it would be, well, go to the scores location and then go up 1 element, which would be an integer, so go up 4 bytes, and then start reading there. You don't need to know that. Just know that the first element starts with 0, which means that the highest index in our array is going to be 4. And I'll show you this here in a second. If I play this right now, we should see 95 printed to our terminal, or to our little output pane. Always takes a second to build the first time. And so close, there we go. So it printed out 95, perfect, exactly what we thought. And if I try to print out the 5th element, I'm going to get a crash, which hopefully you'll see here in a second. Well, let's start talking about why we're going to get the crash before we actually see it. There we go. I've got this exception in main thread array index out of bounds exception. That should give you a clue, and it'll even tell you exactly where it was. It happened on line 8, so I know that it's here. That occurs because there is no index 5, right? 0, 1, 2, 3, 4. 4 is my highest one. If I want the last element, I would say scores sub 4, and that will print out 56. So we have the ability to access individual values. I could also use that exact same thing to change a value. So let's say I wanted to, how about this? Before we print out that last element, I'm going to say scores sub 4 is actually equal to, they didn't get a 56, I transposed that, they got a 65. Okay, so now when I print this, and I print the 4th score, I'm going to get 65. So you can use the assignment operator to set the values for any of the individual elements. Now, what if I want to print out all of the elements? Or what if I want to figure out what the average score is? Well then, I'm going to have to find a way of accessing all of the elements inside of the array. The easiest way to do that is with a loop. So loops and arrays go together really, really well. So let's get rid of these lines. And let's go ahead and just start out by just printing these values. So if I want to print out all of the values in the array, I could say for int I equals 0, because 0 is our first index, right? I less than 5. 5 is the size of our array. And by the way, remember, I is less than 5. That means that I will never actually be 5. Once I will get to 4, which is our highest index, then by the time it actually gets to 5, that's no longer true. It's not less than or equal to. It's just less than, so it's going to exit the loop. We're not going to get an out-of-bounds error. That's fairly important to remember. And so inside of that loop, we just need to actually print out our value. So this is going to be scores, and here I'm going to do sub I. You'll notice I say sub. It's in square brackets, but it's more sort of meant to represent sub notation, like when you have a little, number sort of lower than and smaller than the surrounding letters. So we say sub notation, even though it doesn't look like sub notation, but that just refers to the index at that particular value. And here I'm going to use I. So the first time we go through this loop, I will be 0. So it's going to be score sub 0. That's the first element. The second time we go through this loop, we're going to do I++, so that's going to add 1 to I. And so then scores will be 1. Or sorry, I will be 1, so it'll be score sub 1, which is the second element, 89. And that's going to continue going on until we get to score sub 4. Once we get up to 5, that's no longer true, so we exit the loop. And if I were to do that, you will see that we print out in order all of the elements of the array. Right? All 5 elements. So I have the ability to traverse through a loop. Now there actually is another way, by the way, to traverse through a loop. I'm going to actually go down and just do a new one. So this is going to be, it's sometimes called the enhanced for loop. Oh, actually, before we go on to the enhanced for loop, I want to say there is a way to make this better, which is that if I were to add a value for some reason, right, all of a sudden now my code fails, right? It printed out all the values, or it will here in a second, but it stops at 56. It doesn't print the 98. The reason it doesn't print the 98 is because I've hard-coded what I thought the length of that array was, when I don't have to do that. Java arrays actually know how large they are, right? Unlike C++, if you've ever taken a class like that. So that means that I can actually, access a property of that array in order to get the size of the array. In this case, we're going to call it the length of the array. You can see code complete is actually suggesting that for me. .length. So scores.length will always give you the length of the array, which, so long as you're using a less than and not a less than or equal to, means that the highest number you'll get to in your loop is the number right before the length. So in this case, our length is now 6. So we'll keep going until I is 5, and then when I is 6, it'll exit, which means we won't go off the end of our array again. So if I print it now, you'll hopefully see it prints all the values, including that 98 at the end. All right, so now another way of doing this would be to use an enhanced for loop. So an enhanced for loop is a little bit newer. It's a way of essentially traversing an array. It's a little bit easier to write. You don't have to do a classic for loop, but it is less useful. And I'll show you how it works. So here, I just want to refer to something, right? So I'm going to say for int score colon scores. So now what does that do? This is saying for int score, in other words, I'm going to create a new variable called score. And what this for loop is going to do is it's going to go through the scores array. Even though we do a colon, we're going to say for int score in scores. And yes, these two things look very similar. If it helps, you could just say for int s. But this is actually really common in production code because score is the singular score that you're getting each time you traverse the scores array. And so basically what happens is I create this variable, and then I go through the scores array. And the first time we go through this loop, I'm going to take the first value, 95, and I'm going to assign that value to score. So now I can use the variable score inside of this loop, and it will just refer to that individual score, like the first one. The second time the loop goes through, it'll refer to the second one. And the enhanced for loop is smart enough to know to not go off the end, but it's going to hit every single element in the array in order, and each time it will just take that value. So the second time it goes through, it's going to grab 89, and it's going to assign that value to this variable. Now here's the thing. If it's assigning the value to the variable, that means that I can use that variable to do some math, to print stuff out, whatever I want. But what I can't do is then if I make a change to that variable, I'm making a change to this score variable, which is just going to get reinitialized with a new value the next time the loop goes through. But I'm not making changes to the original array. So if you actually need to make changes to the original array, you have to use the classic style for loop. There's no other way around it. This one won't do it for you. But if you're just doing some quick math or you just want to print out some quick values, it's a very quick way to write it. The classic way always works. This doesn't work if you need to actually edit the original values in the array. But let's go ahead and use it for an example. Let's say I want to quickly print out the average of these values. Right? So if I want to print out the average, I need to keep a running total of everything. That means I need a new variable. So I'm going to say int total, we'll say equals 0. Then inside total plus equals score. Now, this is a combination operator. If you don't remember what that does, it is the exact same equivalent as total equals total plus score. So basically, I take whatever the current value of total is, 0. I add score, which is to be the first score the first time, 95. So that means this expression here will have the value 95. I then take that value and I assign it back to the original variable. So now total has the value of 95. The second time we go through this loop, total is going to have the value of 95. Score is now going to refer to the second one. So I'm going to add 95 to 89, which is going to be 184, right? So that this evaluates to 184, and then I'm going to assign that back to total. Total now has the value 184, and we keep going. So it just creates a running total. It's just a little bit easier to use the combined operator that does both in one. Does the exact same thing. It just keeps adding on to total as we go. Now that I'm done with that, I have this total variable. To get the average, all I have to do is divide the two. And so I can do a system out and say average, and maybe concatenate that with, we have to convert this to a string. Oh, sorry, never mind. Doing Java over here. And so then I just need to convert that to, or have to calculate what the actual average is, which should be the total divided by scores dot length, right? So that'll be the total number of scores. Should work. Scores dot length, by the way, is an integer, and total is an integer, which means that we are going to end up with integer division here, which is going to truncate any decimal places. Because an average often has decimal places, it might actually be more appropriate to turn total into a double, or we could potentially cast one of these two values as a double. I don't want to talk about casting right now. We're focusing on something else. So by making that a double, I'll actually get hopefully what I want. And if I press the play button here, we now print out all the values with this for loop, and we will calculate the average with this for loop, and I guess a little bit of math afterwards. So there we go. Here are our total scores and the average score for the class. All right. Pretty straightforward way of using loops. And so these are sort of the basic ways of using a standard array. But what if you don't know how many scores you're going to have when you're writing your program? For that, you're going to need a different something. You're going to need an array list. All right, so array lists. Array lists are like arrays. You can think of them like arrays, but just picture an array that can grow and shrink dynamically, like in code, to sort of meet the size of whatever data you're talking about, right? Like, I don't have to create 100 values for scores because I don't know. I may only need 12. So I only need 12. I only really need 12 elements, right? Why use a bunch of memory, reserve it when I'm not going to use it? Why, maybe 100's not going to be enough. Like how many friends are you going to have on Facebook? How many likes is that TikTok going to get? Right? Like, I don't know the answers to these things. And so it makes sense to create a data structure that grows or shrinks a little bit. Now, normally this uses sort of templating syntax, something from generic programming. So you wouldn't always necessarily cover it here, but it's really, really similar. And so I essentially always add array lists in with arrays, just so that you've got some options in terms of creating stuff. And generally, you can use both interchangeably. I'm fine either way. If you want to use an array list for something instead of an array. But in general, here's how we're going to first declare one. So we need to create an array list. Now, array lists, like I said, use a certain syntax. It's called templating syntax, and it uses these angle brackets. And so the idea is that inside those angle brackets, we're going to say what type of data this array list is going to hold. So it could be, let's say, an int, right, like our arrays, or it could be something like a string with an R. And so we'll do strings. Now you'll notice that it's in red, right? That's because I have to hit Alt Return here in IntelliJ, or I guess, click in the red and hit Alt Return. And then that's going to add that import Java utility Arraylist. It doesn't come as part of the standard Java language. It's one of the Java utilities that you can import in or not use, depending on whether or not you need it. But now that is the type. It is an array list that holds strings, and now it just needs a name. So I'm going to choose, how about shows? Now to allocate an array list, I think you could possibly use a literal of some sort, but usually you should start with an empty array list. So to start with an empty array list, I'm going to do new array list. Remember, the type actually has that in there, so string, and then after that, open close parentheses and semicolon. Just like creating a scanner, just like creating a random number generator, just like creating an array, if you're using the new keyword because you just want to start it off empty, this is going to create a new array list object that holds strings called shows. Yeah, the only thing that's a little bit different, I think Java version 7, they made it so that you don't have to put the string there. You can use what they call the diamond operator, which is essentially just an empty set of angle brackets. Does that help? No, I don't. It's just, I guess, slightly shorter, but that is also acceptable. It basically will interpret the array list based on the type here. So you're fine. So now I've got an array list of shows. I can add shows. I would do that using method calls. Everything with array lists are going to be method calls. So I can add, let's say, Rick and Morty. Right? So the first element in my array list is Rick and Morty. How about shows.add, and let's say, what's the one that everybody's talking about right now? Oh, The Witcher, that's right. So sticking with the sci-fi fantasy stuff. Maybe add a third one. I got Rick and Morty, The Witcher, and how about a show I just recently, what's it called? The Stewardess? Stewardess? Stewardess. I don't think that's the name of it. The Flight Attendant. That's the name of it. It's on HBO. Little thriller. Doesn't really matter. The Flight Attendant. So here I've got 3 different shows put into my array list. Whenever you use the add method and you just send it, in this case a string, because our array list holds strings. If it was integers, I'd send integers. It always adds it to the end. So now if I want to print this, I could do for string show in shows, and usually don't put a space there. I don't know why I did that time. And so then I could just do my s out and show. So this will print the different shows that I have in my array list. And we can kind of see that they're in order, and they're in order because every time I said add, it added it to the end. That's old stuff there. So Rick and Morty, The Witcher, The Flight Attendant. Now, if I want to add to a specific location, right, I can do that too. Shows.add, but this time I'm going to put in an index first. So let's say I want this to go right after Rick and Morty, but before The Witcher. So I want it to kind of not replace The Witcher, but get inserted where The Witcher is, and then push The Witcher and The Flight Attendant down one. I can do that. I just have to say I want it to go to index 1, right, which is the first place. And notice I don't type index. That just gets typed for me by IntelliJ. It's trying to help me out. And then I just need a show. So let's say, Family Guy. Oops. There we go. So now when I print this, notice I'm printing, keeping the print down there. We'll see that it's Rick and Morty, then the Family Guy, then The Witcher, and then the Flight Attendant. Haven't deleted anything, didn't replace anything, but by using the add with an index, I'm inserting, and then anything that was at that position or after gets pushed down some. I can also remove something if I want. So I could say, at this point, they are indexes 0, 1, 2, 3, right? So I could remove the last show by saying shows.remove 3. Then print them out, and you'll notice that I'd get the exact same thing, except I don't get the flight attendant. Actually, I shouldn't have removed the flight attendant. I should have removed the witcher, so you could actually see this behavior. Because when you get rid of something using remove, you don't end up with a blank space in the array list. Everything that was to the right of whatever you remove collapses down. And so the flight attendant went from the 4th element to becoming the 3rd element. All right, so we've done add, we've done remove. Oh, how do I actually get a value? So here, I kind of did that without, but let's say I wanted to, I'm just going to comment this out real quick. Command slash. Let's say I just wanted to print one value. I could do s out, and then I would do shows.get, and then pull up a specific element. So let's say I want element 0. What's the first show? That's what I want to print. And so get will return just the one element at that index. I get Rick and Morty, and that's what I end up printing out. So shows.get to get the value at a particular index. I've already done remove. Oh, I will get rid of my, actually I can just leave it there, that's fine. We'll just print Rick and Morty twice. So I've done the get, and I've showed you, or sorry, add, and I showed you how when you add, you can actually insert and then push everything down. But what if I want to replace an element? So here I've got Rick and Morty. Well, we got rid of the Witcher in that one, then the flight attendant, and then Family Guy. So let's say I want to replace the flight attendant. We've added a lot of stuff here, so we kind of have to keep remembering. The flight attendant was index 2, but when we removed the Witcher, it became index, wait, oh no, because we added Family Guy to 1. Sorry. Rick and Morty, Family Guy, Witcher is 3, flight attendant 4, but then when we removed 0, Rick and Morty 0, Family Guy 1, The Witcher 2, Flight Attendant 3, we removed The Witcher at 2, so then Flight Attendant is now in position 2. So let's say I want to replace Flight Attendant, right? I don't want to like insert something so that Flight Attendant's still there. I want to replace it. Then all I would do is do shows.set. So set will actually allow us to set a particular index to a thing. And you can kind of see I'm getting this little like hint above where my cursor is. It says int index string element. It's telling me essentially what set is wanting from me. So again, IntelliJ is giving me lots of little hints on how to use these things right. So I'm going to replace 2. So I'm replacing the flight attendant with, oh yeah, the Watchman. There we go. An even better HBO series. So replacing 2 with the Watchman. Now when I print it, I'm going to be honest, we made a lot of edits. I believe it's Rick and Morty, Family Guy, The Watchman is what we're going to see. Well, we see Rick and Morty twice because I have this extra print somewhere. But yeah, Rick and Morty, Family Guy, The Watchman, right? Basically, I have an array that can grow and shrink to be as big as I want it to be or as small as I want it to be, and I can replace stuff sort of dynamically throughout. Probably the most annoying thing about array lists is that arrays have a property called length. It's not a function call, it's a property. When they created array lists, instead of giving array lists a property called length, they gave it a method called size. Between all the different languages, the difference between size as like a property with no parentheses at the end, size as a method with parentheses at the end, length as a property with no parentheses at the end, or length as a method with parentheses at the end. Like it changes all the time with every language. And so generally between one of those four things, I can generally, there's also count sometimes. Something dot count. Point being, with this, if you want to see what the size is, you just do show, or well, here I'll do the S out so we can actually see it. Shows dot size, and it's a method call. And so at the end, we should see that the size of this is 3 because we added some and deleted some. Yep, the size is 3. So that is an array list. It's like an array, a little bit more dynamic, uses this sort of strange templating syntax. But with that, you have a data structure that can grow and shrink to be the right size for what you need. It allows you to add stuff, remove stuff, insert stuff, replace stuff, find out what the length is. You have a lot of freedom in how you're manipulating your data. So I like them. They're similar to arrays. If you find this more helpful for any of your assignments, feel free to use it. And that is all for arrays and array lists. Hopefully you found that helpful. Hopefully you found it helpful for your project this week. And yeah, if you have any questions, be sure to message me. Good luck.